Hello guys and welcome back to another video. I hope you guys are doing great. So the topic of today's assignment is neural network. Hope you've already checked the previous video where I have explained the concept of neural network. Now if you haven't checked it already, then you must go and check it out to understand the concept of neural networks. Now we will begin with the overview of our problem that is given here. It says, as a business analyst at a large retail chain, we have been asked by the marketing team to help them target ads to their existing customers. Now, instead of sending the same advertisement to everyone, they feel that certain customers are more likely to purchase certain products. So they would like to use specific advertising. We have a database of our clients and we will be using some of their demographic information along with the information of department from where most of their purchases come from. So let's begin with question 1. It says, read in the data, make a scatter plot and then describe it. So we can read in the data and then store it in the variable ANN_data. After that, we can check the structure of the data. Now, as you can see, there are 8 variables and there are 1000 observations of it. We have variables like age, income, number of children, purchases, etc. You can also check the summary if you want to know more about the data, but that is the usual stuff, so I'm skipping it. You can even check the NA values, but I have already done it and there are no NA values, so I'm skipping this step as well. Now let's make a scatter plot. So we will make the scatter plot for continuous variables only, and the continuous variables are age, income and purchases. So these variables are stored in column 1, 2 and 4. So we can use the plot function and give our data as the argument and then subset the data to get only those columns which has these 3 continuous variables. Now here you can see the scatter plot is printed. So an explanation is given here, so let's read the explanation. It says all the data is spread in random fashion and there seems to be some heterosketasticity. Recall the concept of heterosketasticity that we had discussed in the previous module. So heterosketasticity is nothing but unequal variance or unequal scatter. We have already covered this in the previous module, so I'm not going to explain it again. Now let's read further. What does this explanation say? It says that it is likely that they are not correlated, but in reality, it is a common sense that these variables should have correlation. However, this is not being reflected by the plot matrix, and therefore we cannot conclude anything. So guys, as you can see, this also happens sometimes, where your data is saying something and common sense is saying something else. So that is the reason we cannot only blindly follow the data. We must also use common sense, we must also use the business knowledge, etc. So data science is a multifaceted approach. You cannot just blindly follow data. You must use the information of the data and also apply the knowledge of the trade. That is what is required to excel in data science. Anyways, moving to next question. Question 2 says, prepare the data for the neural networks. So what do we have to do here? First, we will scale the numeric variable with min-max normalization. Then we will make indicator variables for the dependent variable, that is membership level. Then make indicator variables for the independent variable department. Now why we are doing it, I'll explain it later, but let's start with our first step. So we will use sapply function for scaling the variables as we did earlier. Now here we are only scaling the continuous variables, which are stored in 1, 2 and 4 column. So this will be our first argument. Then we'll supply a customized function for min-max scaling as shown here. And then we will store the results in the variable scale. Now once scaling is done, we can then store it in our original data frame, which is stored in the variable ANN_data. So we can use cbind function here. The first argument is the scale variable The second argument is the data frame. Make sure to exclude those continuous columns that we have scaled, which means 1, 2 and 4 column. Then we can convert the entire output into a data frame using as.data.frame function and store the results in the variable ann_data.scale. Then we will make indicator variables for the dependent variable, that is membership level. Now, why are we making indicator variables? The answer is given below. For neural network, we need Boolean expression, that is true or false. Now, as there are more than 2 levels, so we will have to create dummy variables equal to number of levels. Had it been there only 2 levels, then we could have simply replaced it with true or false as applicable. So we will create 3 dummy variables, and in each variable, value will be written true when a particular factor is found, else it will be written false. For example, in a new variable gold, which we are creating below, wherever gold is matched in the original variable membership level, it will return true, else it will return false. Similarly, it will be done for the other 2 levels of a dependent variable membership level. The other 2 levels are bronze and silver. So here you can see we are creating dummy variable. First dummy variable is gold, and in the C function, we will subset the variable membership level from our data and then equate it to gold for creating our first dummy variable. So wherever gold is appearing in the membership level, it will return true, otherwise false. So this C function will return a vector with values as true and false. Then to add this column to our data set, we can simply use a $sign, give the name of the column, and the results will be stored in this column. Similarly, we can do it for silver and for bronze. So that's how we have created 3 indicator variables. Now similarly, we can make the indicator variables for our independent variable, that is department. Now I already knew what are the 3 levels given in the membership level variable. They were gold, silver and bronze. But let's say I don't know what are the levels given in the department variable. So first we will check how many levels are there in our department variable. For this, we can use the levels function, subset the department variable from our dataset and run it. It will return the levels which are there in the department variable. Now you can see there are 4 levels in the department variable: electronics, hardware improvement, home or bath, office or school. So now we will create 4 indicator variables. We can create the indicator variable exactly the same way as we did above. The only change here is that instead of giving the names of the levels manually, I have used the levels function and then subsetted it with the level number. So this one will return the first level, which is electronics. This one will return the second level, which is hardware/improvement. Then this one will return the third level, which is home/bath, and so on. You could have even given the name manually, but again, I don't like to hard code my code. So we will store these variables in the respective columns and add it to our data frame like so. After this, we will also have to remove the original variables as we have created the dummy variables now. So what were the original variables? Membership level and department. So we can remove it like so using -sign. The column numbers are 5 and 8. So this way we have removed the original variables. Now we will move to the next question. It says divide the dataset into training and test. So first we will set the seed. Then we will create a training variable using sample function. First argument is the vector from which sample is to be taken. Second argument is the sample size. So we are creating a sample of 1000 observations which is equal to the number of observations of our data. But if you see our first argument, then only observation where true will be returned will be considered as training observation, and where false is returned will be discarded. Then replace is equal to true, and that's it. Our training variable is created. Then for creating the test variable, we will use exclamation mark before training variable, which means if there is any observation in the training variable with a value of true, then for the test variable it will be false, and vice versa. This way our training and test observations would be completely random. Now we could have also done an 80-20 split. It is completely up to you. I'm just creating samples with different techniques. You can come up with your own technique. The idea is to bring more and more randomness in the samples. Now let's move to the next question. It says run a neural network and interpret the results. So we will use neural net function for creating a neural network. But first we will have to create a formula that is to be used in neural net. But why are we creating a formula? Because we will have to supply this argument to neural net command. And as we have few columns that are dependent and few are independent, then every time writing them again and again does not make sense and is simply more efforts. So that's why we will create a formula and avoid any extra effort. However, it is not required at all. But I just wanted to show you a different way of doing it so that you can also learn something new. So let's see how we can create this formula. First, we will load the library neural net. Again, you'll get these warning messages. You can ignore it. After that, we will create a variable and call it name. This variable has all the names of the columns of our data frame ANN underscore data.scale. So we can simply use the names function and provide a data frame. This will return the names of all the columns. Then we will create the second variable by the name formula. This will store our formula. We will use s.formula function and then use space to concatenate gold plus silver plus bronze and a tilde sign. Then again use space function and subset the name variable that we have created above. This variable has names of all the columns. So we will subset it using exclamation mark with name followed by a pipe operator. And this will be followed by vector containing names of a dependent variable. So these pipe operators, we had discussed this already. Now this particular operator is used to check if there is a match or not for its left operand. So in short, what is happening here? This will check all the values stored in names variable. Whichever will not match with our right hand side vector, that is gold, silver and bronze, it will return true, and if it matches, then it will return false. Now why did we use exclamation sign before name? Because we want to return true if it's not a match. So if gold, silver, bronze is present, then it will return false, else it will return true. Because the dependent variables are required on the left hand side of the formula, and that we have already written here. Now we only need the right hand side of the formula that will have only the independent variables, which will come from the spaced function. Finally, we will close the space function using collapse is equal to plus. This will put a plus sign after each name of the variable. After this, we can run this and we can see the formulas printed here. Now you can see our formula is similar to the formula that we use in regression. On the left hand side, we have the dependent variable, that is gold plus silver plus bronze, followed by a tilde, and on the right hand side, we have all the independent variables. After this, I have included an explanation. Again, if you have any doubts, you can refer to it and get more clarity about it. Also, as I said earlier, this is not at all required. However, I just wanted to explain you something new. That is the reason I have included this. This could come very handy when we have more variables and we have to create models again and again. Now let's move on to the next part, which says create a neural network with 2 hidden layers and 3 neurons per layer. So we will use neural net function. The first argument is the formula that we have created above. Then the second argument is the data, that is ANN underscore data dot scale. We will subset it using the square brackets to create the model only on the training data. Then in hidden layer we have mentioned 2 and 3, which means it will have 2 layers with 3 neurons each. Then in algorithm we have mentioned backpropagation algorithm. Then the activation function is given by act.fct argument. We have mentioned logistic here, which means we are using sigmoid function. Then err.fct is for error function. So here we are using SSE, that is sum of squared error. We could have also used cross entropy as a cost function. Then we have linear.output as false. It is only true if we don't want to apply activation function on the output neuron. Then learning rate is only used for backpropagation algorithm. So I have given a random value to it. Now these are few basic arguments for creating a neural network. After this we can run this and store our first neural network in neural.1 variable. Now below in the explanation, I have explained the arguments that we have just discussed. So we can skip this and move to the next point, which says which error to use. Now you may be wondering why we have used SSE instead of cross entropy, or how do we choose between the two. So for a neural net classifier, during training you can use mean squared error or average cross entropy error. And average cross entropy error is considered slightly better. If you are using backpropagation, the choice of MSE or ACE affects the computation of the gradient. But then after training, to estimate the effectiveness of the neural network, it is better to use classification error. So as I said earlier, we could have even used cross entropy error here. But that's not the point, as our focus is on learning the method and knowing what all arguments are available. Right now we are not so much focused on getting the accurate results. Once we have understood the process, then we can tweak different hyperparameters and improve our results. So that is a secondary thing. After this, we can plot our neural network using the plot function. Now the plots are being displayed in a separate window. So I will show you the plot now. Here in the plot, you can see the hidden layers, input and output layers. You can also see weights are assigned to each neuron. And then the error is also printed at the bottom. So that is how our first network looks like. Now let's go back to our previous window. Next question says, create neural network 2 using rprop plus algorithm. Now what is rprop plus algorithm? I'll explain this in a bit. But first let us create a neural network and call this neural.2. Now here all the arguments will remain the same, except that in algorithm we have mentioned rprop plus instead of backpropagation. Also I have changed one more thing, which is the number of hidden layers. So here I have mentioned hidden is equal to 3. It means it will have only one layer with 3 neurons. Now why I have done it? Because when I was running the code, so the model was taking a lot of time to converge. This is because I have a very basic laptop, so sometimes it takes time. But again, as I said earlier, our purpose is to learn the method and we are not very focused on getting the accurate results. So these will be the arguments for our second neural network. We will run this and store it in the variable neural.2. Now in the explanation, I have explained what is rprop algorithm. Now rprop algorithm is being used as a replacement for backpropagation, and it is a complete algorithm. Ultimately, it is also calculating the weights. So the purpose of any algorithm in the neural network is basically to calculate the weights. That can be done either by using backpropagation algorithm or we can use rprop algorithm. But the advantage here is that rprop algorithm is more efficient and faster. Now there are various versions of rprop algorithm, rprop plus, rprop minus, irprop, etc. This is a different topic altogether. However, according to one paper, irprop plus works the best. Now if you are interested to more about this algorithm, you can go on the internet and read more about this. But I think we have already learned backpropagation algorithm and we understand its use. So there is no point of learning the theory at this point, and we can directly jump in R and use different algorithms. Now we'll move to the next part. It says plot the network. So again we can use the plot function and plot our network. Now I'll show you the network, which is open in a separate window. So here's our neural network. You can see different layers. You can see the weights. And you can see the error here. Now the next part is asking us to create another neural network using rprop plus algorithm, but this time use two hidden layers and plot the network. So all the arguments will remain the same, except that we will mention hidden is equal to C, 2 and 3, which means two hidden layers with 3 neurons each. We will run this and store it in the variable neural.3. Then we can plot the third network using the plot function. So here we have our plot. Now if we compare all the three networks, we found that network 2 has the lowest error. Hence we will use this network for making the predictions, which is our next question. Now question 5 says, use the best model to predict the test data and check the performance. So for prediction, we will use compute function, which is a part of this neural net package. Now to call a function from a particular package, we use the name of the package. So here we have used neural net and then followed by two colons and then mention the function. So in our case, it is compute. After this, the arguments are same as the predict function. Just give the model and then the data set. Now from the data set, we will exclude a dependent variable which are stored in the column 7, 8 and 9. Then we will run this and store the results in the variable predict. Now I am not showing it, but if you write the predict variable, let's store our prediction and use a $sign, you will know that there are two outputs that are written by the compute function. One is the neurons and the second is net.result. Now this net.result is the one that stores the predicted probabilities for each class. So the maximum probability class will be our prediction. Now to find this, we will run a for loop as shown here. First create a null vector by the name res. This will store the results. After this, we will run the loop from 1 to the number of rows which are there in the predicted results. So we can mention 1 colon dim function which will return the dimension. Then give predict, subset it using the $sign and mention net.result. Close the bracket and then again open the square bracket and mention 1. So basically dimension function will return the dimension of the input. And as we only need the number of rows, which will be the first dimension, so that is why we have substituted it again using the square brackets and mentioned 1. Again, we could have simply written the loop from 1 to 213. I am just showing you different ways of doing it so that you get to learn something new every time. Then we will enter into the loop. We will use which.max function and the argument for this would be net.result stored in predict. So we will subset net.result using the $sign. This will return all the values of net.result. Then we will again subset it using the square brackets and mention I there followed by a comma. So what will happen here? This will subset the rows from net.result for the corresponding value of I. So for I is equal to 1, this will return first row of net.result, and then this first row will have 3 probabilities. So which.max will return the index / position of that probability which corresponds to the maximum value. So for example, let's say first row of net.result has 3 probabilities as 0.4, 0.5 and 0.6. So which.max will return 3 as 0.6 is the maximum probability and the index or the position of 0.6 is 3. Now this 3 will be used to subset the name of the class from the vector given here, which is gold, silver and bronze. So if which.max has returned 3, so our vector will be subsetted and will return bronze. If which.max will return 2, our vector will be subsetted and it will return silver, and so on. So this way loop will run from 1 to 213 values, and each time one of the 3 values will be returned, either gold, silver or bronze. And this will be stored in the vector result. So that is how we are making the prediction of our class using the probabilities. Now again I have included the explanation here. You may read it if you are still not clear with the loop. After this, we'll create the confusion matrix and see how well our model has performed. So we will use the table function. First argument is the predicted class, which is stored in RES. Second argument is the classes of our test data. So our dependent variable is stored in 5th column, and for subsetting the rows, we have mentioned our test variable. So it will return the 5th column of our test data. We will run this and store it in the variable CF. Then we can also print our confusion matrix as shown here. After this, we can calculate the misclassification error as shown here. We will sum the diagonal elements, then divide it by the total of the confusion matrix, and then subtract it from 1. And finally multiply it by 100 to convert it into percentage. Now here you can see our misclassification error rate is printed. The misclassification error rate is quite low, which is really good. So with this we can wrap this up and say that after running few neural networks and by varying few parameters, we found that RPROP algorithm with 1 hidden layer and 3 nodes has the lowest error. So that is how we create different neural networks and select the one that perform good on the test data. So that will be all from this assignment, guys. Let's quickly revise what we have learned so far. We started by plotting a scatter plot and interpreting the results of scatter plot. Then we have learned to create dummy variables for a neural network. We also learned to create the formula that is given to neural network function. Then we created 3 different neural networks. We first created using the backpropagation algorithm, and the remaining 2 we created using the RPROP plus algorithm. After that, we also understood various arguments passed through the neural net function. We also plotted the network. Then we selected the best model based on the error and made the prediction using our test data. And we saw that our prediction accuracy was really good. So we will end this assignment here. And in the next assignment, we will be learning neural network for regression. I'll catch you up in the next video. Until then, see you.